The graph shows the variation of displacement with time for two waves. What is the phase difference between these two waves? So remember that phase difference must be expressed in degrees or radians. So actually, from that we can straight away rule out option A and option B. It can't be those two things because neither of them are in degrees or radians. We can make this easier for ourselves as well by considering the two options that are left over, C and D, pi radians and 90 degrees. Pi radians has a very specific look. If two waves are pi radians out of phase, or you would say the two waves then are in antiphase, they would have a very specific look. One of the waves would look like this, and then the other would look like this, doing the exact opposite of the first wave at any one time. That's not what we see here. And if that's not what we see here, then we can also rule out C. So we're left with D, that would be our answer, 90 degrees. We can understand that more by considering the graph. So if we look at two crests, two adjacent crests, let's say this one and this one, and if I go down from that second crest to the time axis, which is around there, I see that if I look at the wave that's represented by the dashed line, this point right here, that point there, is a quarter of an oscillation from this point. That's 1/4 of an oscillation. This is one full wave to there. This is half a wave. This is a quarter of an oscillation. So this crest is therefore a quarter of an oscillation from this crest. And if they're a quarter of an oscillation apart, a quarter of 360 would be 90 degrees, and that's why the phase difference would be 90 degrees.